we need to define what is known as the standard ABC triangle. The standard ABC triangle is given over here. We can see capital A and capital B. Those capital letters define the angles in our right ABC triangle. Then we can see the hypotenuse is always going to be the letter C. And if you look, the side opposite angle A will be labeled little a, and the side opposite angle big B will be labeled little b. So this is the setup when they talk about an ABC triangle, right? Triangle. This is always going to be the setup. You can put the angle A and the angle B anywhere you want, but once those angles are set, the side little a is opposite angle big A, side little b is opposite angle big B, and little c is always the hypotenuse. That way it jives with our favorite theorem, the Pythagorean theorem. So if you look, how we're going to be given problems is going to look like this. We are going to be given that the length of two of the sides using an A, a B, or a C, and then they're going to ask us to find the 6 trig functions of one of the particular sides. So what I like to do is I like to draw myself a little ABC triangle like this, and then I like to say, okay, side A, that's a 5, side C, that's a 9, and now, how can I find side B? Well, remember, this is a right triangle, so our favorite theorem, Pythagorean theorem, leg squared plus leg squared equals hypotenuse squared, can be used to find that missing side. So 25 plus b squared equals 81. So b squared is going to be 81 minus 25, which is 56. Square root both sides. Technically, this should be plus or minus the square root of 56, but because we are using side lengths, that's going to be a positive 56. And then we need to kind of think, can we break down this 56 into a better square root? Well, yeah, actually 56, that's 4 times 14. So 56 is actually 2 square root of 14. So remember, go back and look at some of the reviews if you don't remember how to simplify that, or use your calculator to do that simplification. So side B is going to be 2 square root of 14, and we can put that in there as our third side. Once we have the sides labeled, now we need to go back to our SOHCAHTOA. I would like everyone to write this down until we get really good at it. SOHCAHTOA. That's how we have to remember to do these. So sine, and they're telling us to use angle A. Sine of angle A. Okay, let's be careful. 9 is the hypotenuse. 2 square root of 14 is on making up the angle A. So this is our adjacent. And that means that side 5 is opposite. So opposite over hypotenuse. That's 5 over 9. Not too bad. Cosine of A. Adjacent over hypotenuse. That is 2 square root of 14 over 9. Tangent, TOA. Notice that you do have to write that angle letter A. So TOA, opposite over adjacent. That's 5 over 2 square root of 14. Now, you can't leave a square root in the denominator. So what we're going to do to fix this and not have a square root left in the denominator is we're going to rationalize. Remember, that means multiply the top and the bottom by the square root. On the top, we'll just have outsides with outsides, insides with insides. That gives us 5 square root of 14. On the bottom, square root of 14 times square root of 14 is just 14. So we'll have 2 times 14. So tangent of alpha is going, or tangent of A is going to be 5 square root of 14 over 28. Whew, that one was a little bit trickier than it looked because we had to do that rationalizing. You must be able to do that rationalizing and do it quickly if possible. All right, let's go through and get the other 3. So cosecant, That goes with sine. Remember, since sine isn't a it gets the cosecant. We're just going to reciprocal sine. That's 9/5. Secant of A, we're going to reciprocal cosine, but again, we're getting that 2 square root of 14 in the denominator. So since we've already done this once, remember what happens. The square root from the bottom goes to the top. That'll give us 9 square root of 14. And then the bottom is just going to become a plain 14 times our 2, which is our 28. So we can rationalize that secant really quickly. Now here's a little trick. When we do tangent, it is tempting to take this one and flip this one over. But actually then we're going to have a square root in the denominator again, and we're going to have to re-rationalize, and that's a little bit icky. So what we can do instead is we can go all the way back over here to before we rationalized and flip this one over. And when we do that, our square root of 14 is on the top, our 5 is on the bottom, it's fully reduced, and we don't have to re-rationalize. So this is a nice basic problem using a standard ABC right triangle.